Okay, as we talk about domain and range and continuous and discrete, this first problem says Mary wants to purchase some music from an online music store. The store charges a one-time download fee of $3. And then each song costs $1.25. Okay, so let's skip the equation part for a minute. Let's fill in the table. What are the two things that we're talking about? We're talking about downloading what? Downloading songs or music. Okay, so I've got the number of songs. And then what happens after we download the songs? We have to do what? You have to pay for them, so it's got to be the total cost. So before we write the equation, sometimes it's easier to build a table. I'm going to skip the first line on your paper, and let's go to the second one. If I download one song, how much is that going to cost me, does it say? One song, it's not just going to cost me $1.25. What do I have to pay first? I have to pay the $3 first, because the $3 is going to allow me to download it, right? So you have to pay the $3, and then you pay the $1.25. So one song is actually going to cost me at first $4.25. See, before I can download, now this is why I said skip it, because on 0 right here, before I can download anything, you have to pay to join. Basically, it's like you have to pay to join the site, right? The one-time download fee right here would be $3. So how much is two songs going to cost us? What do you have to increase by? $1.25. So now it's going to be $5.50, right? 3 songs, another $1.25. So that gives me $6.25. 4 songs, $7.50. 5 songs. Did I mess up? What did I mess up on? Woo, okay. Yeah, I thought I messed up there. There we go. So, all right, let's see. $6.75. Now this goes up by $1.25, which gives me $7, right? Then $8.25. Where did I mess up? I'm so glad you are a smart class. It is $8 right here. And now $9.25. That's what happens when you only have one eyeball. Okay, with one contact. All right. So when I go up here to write my equation, remember that this is x, this is y. Y equals, what are you paying each time? $1.25 times x. X is the number of songs. Plus a one-time fee of $3. This is where some people are messed up. Messed up on the last test. That $1.25 is the coefficient. That is what you're doing each time. It's your rate of change. This, the one-time fee, something you pay for once, is your constant. I would make that note in there, especially for those of you that need to reassess. Next, if I go and fill in my table or my graph right here, I've got X, then Y. This down here is going to be number of songs. And this right here is going to be, the Y is going to be the total cost. Now, let's see, I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes up to 10. Number of songs, I'll go by ones. I'm sure it's going to ask us this in just a minute. But when I go to graph this, so for example, when let's go and plot 0, 3. 0, 3, put a dot right there. 1 and 425. Over 1 and up 425. 2 and 550. Over 2, up to 550. 3 and 675. 4 and $8. 5 and $9.25. Now, should I connect these dots? Is this data going to be continuous or discrete? Okay, I hear continuous, I hear discrete. Why are you telling me discrete? Well, I'd graphed it with dots, but I could just draw a line to make it continuous. Why is it discrete? I think it doesn't show every penny. That would be one thing. Gonzalo, what were you saying? Which numbers does it not go through? No, you could go up to 20. Continuous does not mean that it goes forever. Okay? That's one thing I want to make sure that everybody understands. Continuous doesn't mean it goes forever. It means between these two numbers, does it go through every number between 0 and 1? Can you go through and say, I only want to get 0.3 of the song and only pay for 0.3 of the song? You could download 0.3, but you still have to pay for the whole song, right? The thing is, you don't go through and when you're downloading number of songs, you're going to either pay for one song, 2 songs, 3 songs, right? Whole number of songs. So this data is discrete because you're only going to pay for whole numbers of songs. So down here, where'd it go? Because it had the question on there. With the situation is going to be discrete because you will only pay for whole numbers of songs. Now it asks you, give a reasonable domain and range for the situation. Well, first off, what is domain? Domain is the X. I told you guys every time you see domain and range, independent and dependent, you should be writing X and Y above it. Okay? So a reasonable domain. So I'm going to write D equals, what's the smallest X number I'm going to have? Why 0? Give me a number that's smaller than 0. -1. Domain is the X. It's the number of songs. Can you download -1 songs? No, that's not reasonable. It doesn't make sense. So you would start at 0, and then you're going to have 1 song, 2 songs, 3 songs, ... Now, why would I put ... It can keep on going, okay, to a reasonable number. We're not going to download, unless you're Bill Gates, 1,000,001 songs, right? But I'll still do that right there. Now, range. Range is my Y. What's the smallest number I start with on my Y? $3. It has to be 3 because that's the only way I can get onto the site. And then after 1 song, it's 425, 550. Again, it's going to go up. I wouldn't make you have to write all of these. Normally they'll just list them, but they want you to show that you're going up by $1.25. Now, I want you to pay attention right here. If you have a highlighter, or I want you to circle it. Up here in this last one, it says what would the graph of the situation be? And we said the situation is discrete. The difference in number 5, it says what is it of the function? Okay. Well, what does that function mean? It's the same as saying the equation. If you went and put in your calculator, you put in the calculator y equals 1.25x plus 3. And you press graph. Is the graph going to stop and do what we did right here? Is it going to make dots just without you doing anything in it? It's not. What's it going to do? Keep going forever and ever, right? Because the calculator does not understand that we're using it for a situation. So what this is talking about when it says the equation, it's talking about what's in the calculator. And in the calculator, it's going to graph a line. It's going to go through every number and every decimal. So in the calculator, it is going to be continuous. Why? Because the calculator doesn't know the situation. When you're talking about just a function, it's talking about just the basic math, right? Just the numbers. So the calculator, so the graph of the function is what numbers are in the calculator because the function is just all the numbers. We as people with our brains apply the situation. Okay? Now, with that, when it talks about, and that's on every, hint, 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 on every test that we have, when it's talking about what is the graph of the function, it is always going to be continuous. It's the situation that may change. When it asks about domain and range, the domain, well, let me put that right there. The domain in the calculator, it's going to have all the numbers. So what we're going to write is all real numbers. It's always going to be like that because in the calculator, it's going to give you all the numbers. The range is going to do the same thing. All real numbers. Maybe you want to star and highlight that to remember that because hint, 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 you're going to see it again, 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 again. Now on the next one, it says if Mary has $30 to spend, how many songs can she purchase? Justify your solution algebraically and using a table. Okay, so we know I have my equation y equals 125x plus 3, right? Yes, Miss Crawford. Oh, okay, great. So we're going to have $1.25x plus 3, and it has to equal $30. So we need to solve this for x right here. So we would have subtracted 3 from each side, gotten $1.25x equals 27. Then we will divide by $1.25. And x equals, well, let me find my doohickey. My doohickey would be the calculator. Maybe it'll show up here in a minute. Those of you while we're waiting, when you put that in the calculator, what did you get when you put 27 divided by $1.25? Oh, no one got their calculators today. How about we get the, oh, you do? Okay, well then what's my answer? And while we're waiting, for those of you that don't have your calculators, go get them. Well, where did mine go? Why did mine disappear? I needed 27 divided by $1.25. 21.6? Okay. Well, Golly gee willikers. This does not want to open up. Okay, I don't know why. Okay, so you said it was 21.6. Okay, so 21.6. Now, let's talk about reasonableness. How many songs can I download? Why can't I download 0.6? It's not continuous. You have to do a whole number. And if I went up to 22, it's more than $30, right? And you know that's when my children go, oh, please, Mommy, just give me a few more dollars. I just need this one song because it's so awesome. Whatever. Y'all know you do that to your parents. Whatever. Okay, so you can only download 21 songs. What I was trying to show in the calculator was that you can go into y equals and into y1 and put $1.25x plus 3. Press second graph, and you would go through and find where the y was 30. Okay, but you're not going to find that with a whole number. It would be in between two numbers. Okay? So they would be in between 21 and 22. That's where the 30 would be. You wouldn't see it. So sometimes, especially when it's decimals and fractions, it's easier to solve this out by hand. Okay? Let's go and do the next problem right here. The next one says Nina wants to buy a new bicycle and has begun saving money. Last month, she saved $25, and she plans to save $15 each coming month. Her goal is to save $300. It wants us to find the table that best describes the data. What does she do one time? How much does she first put in there the first time? Oh, now, look, now the calculator wants to come up. Really? Okay, what happened? She has 25, so she first puts in the account. When she first opens up the account, where'd you go? There it is. Okay. All right, so when you first put this in the bank, the one-time thing is the $25, right? Then each month, she puts in how much? Whoa. Okay, puts in 15. Sometimes it's easier for me so that I don't make a mistake on figuring out my tables. At time 0, she puts in $25. At the first month, she now puts in $15. So how much total money does she have in there? 40. I thought I heard it. And at the second month, she puts in how much? 55. So now let's look and take a second. Which table is ours? 1 and 40 could be it. This one can't be, right? So it says 1 and 25. 1 and 15. It is A. Now, I want to go back a second. Out of these two pieces of information, I would write this somewhere on your paper. Which one of these things, because this is, again, this is one of the things that some of you guys need to reassess on. Which one of those is the constant and which is the coefficient? Don't say anything. Take a second and think in your head. Which one of these two things is the coefficient and what is the constant? Constant is the thing that happens once. Which thing happens once? The 25. So this is the constant. I would write that right there. Somewhere on your paper. What happens each month? This is your coefficient. Okay? So on your paper, if we go down, let's go down here a second because we just did the equation portion. I want you to remember that we have y equals the coefficient. Write this out on your paper too. X plus or minus your constant. So my equation is y equals, we found that our 15 was our coefficient times x. plus the constant, which was 25. Okay? That was one of the things I really found struggling, that people were struggling with on that first test. Now, when we look back up here, would this situation be continuous or discrete? First off, we're talking about situation. We're talking about this problem up here. Is it continuous? Continuous means I can have fractions and decimals. Am I depositing things 0.6 times or 0.6 of a month? No. These are whole numbers. It is discrete because you are depositing once a month. Once a month. In words, describe the domain and range of the situation. Domain, put X above it. Range, put Y above it. Domain equals, what is the smallest number I start with? 0. Domain and range, X and Y. Because when you first open up the account, you have to put money in it. So you start at 0, and we go up by 1 month, and we can just do it like that. The range, how much did we first deposit? 25. And after 1 month, we had 40. Those of you who don't remember you should have it on your paper right here. 2 months, 55. What was 3? 70. These are both to a reasonable number. I don't think you'd be alive for 1 billion months, but maybe if you just passed it on, I guess. Okay. Now, as we go down below and you look at the next one, it says describe the domain and range of the function. Okay, so down here, it's talking about, let me hide, oh, there, oh, hello. Of the function. Function means if I go in the calculator and put this in the calculator and I press graph. Okay, so I go in here and I go to y equals and I put in there 15x plus 25 and I press graph. Does my calculator know not to go to the negatives? Well, it obviously doesn't know anything right now. Let's try to zoom out. It's because we're outside of our... There we go. Okay. The line is right here. It's going to continue to give me a line. Just like in my table, it's going to give me all the decimals and fraction, or not decimals and fraction, but all the positives and negatives. The domain is going to be all real numbers. Because in the calculator, that's all it always gives me. It gives me every number that's around. Range is the same thing. All real numbers. It's us that applies the situation. It says how many months will she have reached her, in how many months will she have reached her goal of $300? So one way we can do that is to take 15x plus 25 and set it equal to 300. So let's go and solve that. You will subtract 25 from each side. You get 15x equals 275 and divide by 15. X equals. So if I go with my calculator, let's go in the home screen and put in there 275 divided by 15. Does it come out to be a whole number? Nope, it's 18.33333. In this case, what happens? Well, let's go back a second. Let's go on the calculator first. Let's go look at something. So I'm going to go into my calculator and go into y equals and put in there, I've got in there 15x plus 25. And I'm going to go second graph. Oh, golly gee willikers. Let's see here. Let me put in 18 right there. At 18 months, what does it tell me? How much money is that? $295, right? Let me do this. Whoop, whoop, whoop. Okay. Okay, so at 18, it tells me $295. What does it tell me at 19? $310. $300 would go in between here. So can I buy, or do I have my goal at 18 months? No. So how many months does it take? It takes 19 months. It's okay to have more money, you just don't have enough at 18. Okay, now let's go to the next one. I'm going to start you off on this one right here. It says a water tank containing 400 gallons of water has a leak. The water is draining out at a rate of 3 gallons per hour. I would circle that. The amount of water W in the barrel after H hours is found by the equation W equals 400 minus 3H. After 1 hour, how much is left in the tank? Okay, so you can do it one of a couple ways. Let's grab our calculator and go to y equals, maybe, if it doesn't disappear on me. And put in there 400. Can I, and it says minus 3. Do I put an H? No, you put in an X. And then let's press second graph. Actually, I'm going to go second window and go to 0. Second graph. Okay. Maybe. And after 1 hour, how much is in the tank? 397, right? 397. After 2 hours, 394. After three hours, 391. This graph right here, would this be continuous or discrete? What's happening between these hours? I mean, does it go, did it start off at 400 and poof, go to 397? It had to gradually leak out, right? So it goes smaller, smaller, smaller. This has to be continuous because you were talking about how much water is in a barrel and it leaks out little by little. So this situation right here would be continuous. Why? Because the water leaks out a little by little. Okay? Okay, so on this one, when it says describe the domain and range for the situation, okay, even though it is continuous, where'd my board go? Here we go. There we go. Even though it's continuous, my domain still has to start at a certain point. See, D equals, because in a reasonableness, when you talk about hours, Can you have negative hours? No. So you're going to go 0. We'll write it like this. We'll write from 0 to, actually, we'll talk about this in a minute, to so many hours. There's a reason why I'm saying that. We'll talk about it in a minute. The range from, well, what's the gallons? It starts with 400, but what's the smallest amount of gallons you could have in the tank? It's going to go down to 0. So you're going to have from 0 to 400 gallons. Well, how many hours does it take to get to 0 gallons? Well, if I go here in the calculator, oh, that's the wrong button. If I go in the calculator, I'm going to go down and look and see where y is 0. Click, click, click. Oh, you know what? I'm just going to try and put in some numbers here. Second window, let's guess about 40. I'm totally just guessing a number because my calculator doesn't go as fast as y'all. Nope, we're at 200 something. So let's go second window. Let's go to 80. Second graph. I'm getting closer. Second window. Let's go to 95. Second graph. Oh, even closer. So now I'll press the arrow down. When do I get to at 133 hours, we're at 1 gallon. And then we go to negative. So then to the domain, basically we'll go to 100. We'll just go with 134 hours. Okay. Now, what is the domain and range of the function? Remember, the function is what the calculator says. The function gives us all numbers. So the domain is all real numbers, and the range is all real numbers. Now, we already did kind of go through and do this. It says when all the water leaks out. So we're looking to see where y is 0. And we found that in the calculator at, let's see, 133 and 134. So let's see, at 133, there was 1 gallon left. At 134, there is negative 2 gallons. Okay, and to figure out exactly how long it took, you would take your equation 400 minus 3h and equals 0. So to solve this, you would subtract 400 from each side. Negative 3h equals negative 400. Divide by negative 3. H equals, so let's see here, if I go into the home screen, second quit, let's put negative 400 divided by negative 3 and enter. 133.3. So that's 133 and 1/3 hours. If you wanted to figure out what 1/3 of an hour is, well, there's 60 minutes in an hour. It'd be 133 hours and 20 minutes. Okay, the next one right here. Juan is going to rent a surfboard for the next 12 days. So it's going to give us the days and the total rental fee. It's going to have basic fee insurance and the daily rental rate. What is the independent variable? Remember, independent is the X. It's the thing that happens first. Well, what do you do first? Do you pay or do you rent the number of days? This is your independent. So you'll have number of days. Now, your insurance, it says how much is your insurance fee? Insurance fee is a one-time charge. So if it's a one-time charge, it's your constant. And the daily rate is your coefficient. It's what you pay each time. So what do you pay each day? This is increasing by 15, by 15, by 15. So my daily rate is $15. My constant for my insurance, if I took away, to go back to time 0 before the days, if I subtracted off and made the difference back here and took 15 off, what would I be left with? So if I took the 15 off here, I'd be left with 10. That beginning fee is your insurance fee, so that would be $10. Your equation would be y equals 15x plus 10. Now it says, will the domain and range for this equation represent the data be different than the domain and range of the data itself? Oh, what does that mean? It means the equation, when I put it in the calculator, is there going to be a difference between that and the actual data? Data meaning the problem, what it's asking about. Well, first off, yeah, it's going to be different because in the calculator, it's all real numbers. So for the equation, it is all real numbers. For the data, my domain, what does my domain start with? What's my x? This is my domain. This is my range. I start at 0 and go up 1, 2, 3, 4. 0, 1, 2, 3, dot, dot, dot. My range, what's the base that I pay for? I start at $10, $25, $40, $55. So it's certain numbers I pay. So I have 10, 25, 40, dot, dot, dot. Okay, because it's up to a reasonable number. Now, is this data going to be discrete or continuous? It is going to be discrete because you are paying, whoops. It is going to be discrete because you're paying for a certain number of days. You're going to pay for 1 day, 2 days, 3 days. Then it says, how much would Juan pay if he rents the board for 12 days? So I have y equals 15x plus 10. One way you could go in the calculator and put it into y1 and look and see where x is 12. Or you can go 15 times 12 plus 10. So if I do that, I have 15 times 12 plus 10 which gives me 190. Now, if they dropped off the basic insurance fee, how much would he pay? The basic insurance fee is $10. So if I took 190 minus 10, it would only be $180. The next problem, on this next one, it says, Bernard gave Blanca a gift card to her favorite drive-in restaurant. The amount of the gift card is $50. Bianca orders the same thing each visit, a large fountain drink for $1.50. So out of the number of visits and the amount on the gift card, what is the independent variable? Independent is the X. Well, before she can spend any money, she has to show up. The number of visits is the X. The remaining money is the Y. So the independent quantity is the number of visits. Will the domain and range of the equation be different than the domain and range of the situation? Yes, it will be different because the equation contains all the numbers. And the situation is only certain numbers. Now, I'm looking on this right here, and I don't see one of the questions. We are missing the question that says, what is the equation? So let's go up here for a second. Let's figure out the equation. What is my constant? Out of these two pieces of information, what is the thing that's happening one time? One time we're getting the card. This is my constant. This, what we're doing each visit, each time, is my coefficient. Remember, my equation is going to be y equals, we're going to have, and the coefficient is going to go with the x. So y equals, we start with the $50, and then we subtract off $1.50 for each visit. See, the x right here is the number of visits. So here's my equation. Now, if I go down here, it says how many visits will she be able to use her gift card? Well, okay, so the equation is y equals 50 minus $1.50 x. You're trying to look, if you put that in the calculator, you're trying to figure out when her gift card goes to 0. So you can go into y equals and put that in there and look and see where y is 0. Or we can just solve it for 0. So I can go 50 minus $1.50 x equals 0. Well, I can subtract 50 from each side. I get negative $1.50 x equals negative 50. Then I would divide by negative 150. And I would find out what x equals. So when I go here in my calculator, I'm going to put in the home screen negative 50 divided by negative $1.50, and it equals 33 1/3. Okay, 33.33. Well, let's look at this a second. If I go in the calculator and put in there 50 minus $1.50 x, second graph. I think mine's way up there. It sure is. It looks like it's about 33. So I'm going to go second window and put in there 33. Second graph. After 33 visits, how much is still on the card? 50 cents. So basically it's telling me that after 33 visits, she still has 50 cents on the card. So if she wanted to go a 34th time, she could spend the 50 cents, but she'd have to pay an extra $1. The next one, let's sketch an example of a discrete graph. Discrete would be dots. Whoop, let's go back here. Sketch a continuous. It would be a line. The next one says, let's do some function practice here. It says, given the function f of x equals negative 4x minus 6, what is f of negative 3? All it's saying is that negative 3 goes in where the x goes. So like right here. So I would go negative 4 times negative 3 minus 6. Negative 4 times negative 3 is 12. Minus 6 is 6. That's one way we can do it. The other way is you can go in the calculator, go to y equals, put in there negative 4x minus 6, second window, go and see where x is negative 3. I'm going to go to the second window, type in negative 3, second graph. There it is at 6. So you can put it in the calculator and look at it this way, or you can solve it by hand. I'm going to show them by hand. So given the function here, you're going to put 8 in there for x. So you have 8 plus 4, which is 12. Again, to go in the calculator, go to y equals, put in there x plus 4, second graph, go to where x is 8, and the y number is 12. Next one, take negative 10 and put it in there for x. So I get negative 6 times negative 10, which gives me 60. Answer these right here. All right, again, this negative 3 goes in here for x. So I get 2 plus 8 times x, which is negative 3. 2 plus negative 24 is negative 22. Now this one is different because it says given the function, what is the value of x when f of x equals, look at the difference. The number was in the middle here, and on this one it's on the outside. This time, this is going to be our y. So I'm going to take this and put this here. So I would have 14 equals 2x minus 8, and I would have to solve for x. By going in here, I would add 8 to each side. You would get 22 equals 2x. You would divide by 2. X equals 11. Now, if you wanted to do this one in the calculator, x and y, it's giving you the y number of 14, and you want to find the x. So I would go in the calculator, go to y equals, put in there 2x minus 8, second graph, and look and see where y was 14. Right there at 11. That's what I found my answer to be, right here. And so this right here would be 11. Oops, let me move this down. Let's try the next two. If you haven't done them already, pause the video and come back and see how you do. On this one, I'm going to erase some of this up here because, let's see here. me fill that in so that if other people need it. Okay. On this one, we have -4. It says f of x equals, so that's where I'm going to put the f of x is right here. So I'm going to have -4 equals 1/2 x plus 9. So one way is to solve this by hand. So we will subtract 9 from each side. And I get -13 equals 1/2 x. So 1/2, so I will multiply each side by 2/1. By doing this here, these cancel out. And I'll get x equals, right here, when you multiply -2 times -13, it's -26. Using the calculator, you're looking to see where y is -4. So you would go in the calculator, go to y equals, put in there 1/2, 1 divide 2, x plus 9, and press second graph. You would go and look where y is -4. Have to go a little ways down here. There it is, -26, which is what I got for my answer here. The next one, again, you're going to take this -13 and put it in here, right there. So I have -13 equals -2x plus 7. Finding out what x is, I will subtract 7 from each side. I get -20 equals -2x. Divide by -2. X equals 10. In the calculator, you would go and look where y is -13. So I would go here. Let's move this over a little bit. Let's put in there y equals, clear it out, -2x plus 7. Second graph. Look and see where y is -13. Now I think it's -10, so I'm going to go second window because my calculator's slow. And put 10 in there. Second graph. And now it's -12. Whoa. Oh, yeah, it's -13. Sorry, I'm just blind here. So it's 10.